We at Nvidia build solutions to accelerate quantum computing, and CUDA-Q is our platform for accelerated hybrid quantum classical architectures, and NVQ-Link is an open reference architecture for the tight integration of QPUs and GPUs. And Pasqal plays a very important role in both. For example, Pasqal is one of the first QPUs of neural atoms that are integrated in CUDA-Q. That was a pioneering work by Pasqal. And Pasqal is also one of the early adopters and supporters of NVQ-Link as a reference architecture for the tight integration of QPUs and GPUs. So we've been together for a while now in a very long and successful partnership, and I'm very much looking forward to seeing the next steps together. It is true that we speak a lot about heterogeneous quantum classical architectures. And in these heterogeneous quantum and classical architectures, you have classical and quantum resources. So there are a number of challenges. First challenge, let's say, is how we compute in this architecture. How do we program this architecture? And an answer to that is CUDA-Q that allows to very performantly program and compile in this architecture. So that's the first step, and Pasqal is part of this because your QPUs at Pasqal are integrated here. However, this integration, while there is a lot of value into that, we need to take this a step further. And this step is what we call a tight integration. And this is precisely what NVQ-Link does. So as an open reference architecture, NVQ-Link addresses the challenge of how can we very tightly integrate with high throughput and ultra low latency quantum and classical resources. And Pasqal is one of the early adopters of this open reference architecture, which by itself, by being an early adopter, there's a lot of value into that, in my opinion. Now, we build this architecture, we accelerate this architecture because there is for sure an intersection between these heterogeneous workloads and AI. And while there's significant research into quantum for AI, we think more about AI for quantum. In any case, leveraging these heterogeneous architectures is, in my view, crucial to unlock all the possibilities that the intersection of AI and quantum brings. When we think about how we can accelerate the adoption of hybrid AI and quantum workflows in industry and research, I think we need to take into consideration how can we use AI as an accelerator beyond thinking about the infrastructure that we are running that onto. And in my mind, that is a discovery journey. I'm personally very excited about the value that agents are bringing to the table. And it's also very exciting to see, commenting on the hybrid workflows, how Gen AI intersects with quantum. I know there are some works on quantum for Gen AI. I'm less familiar with those. But for example, commenting on Gen AI for quantum, there's an algorithm called the Generative Quantum Eigensolver, developed by some of my colleagues at Nvidia, and also including Alan Spurgusik. And here, what you do is to use GPT logic to generate quantum circuits and iterate with those in this hybrid algorithm, which is a variation of the VQE. So this is an example of how this intersection happens. Now, I'm aware that this answer is fairly technical. So from a more industrial and end user perspective, in my mind and in my view, I also think that they probably need to go through a discovery journey and start experimenting and embracing experimentation and allowing also themselves to maybe make mistakes, which is okay, and learn from those. And leverage all the expertise and help that they can get from the whole community, including Pasqal, of course, and us.